Hello everyone. In today's video, we are going to be solving AQA GCSE Chemistry, June 2021, Foundation Paper, This is a part 2 video, and in this video, we are going to be solving from question number 5 to question number 6, 7. So we're going to be solving question number 5, 6, 7. This question is about acids and alkalis. Which ion do acids produce in aqueous solution? Guys, acid produces H plus ion in aqueous solution, and base produces hydroxide ion in aqueous solution. Acid reacts with alkali. What is the name of this type of reaction? Acid-alkali reaction is called neutralization reaction. Balance the equation for the reaction between sulfuric acid and potassium hydroxide. So, when balancing an equation like this, we will have to look into, see, there is 2 potassium on the right hand side, so we must have 2 potassium on the left hand side. Okay, there is a total of 2 hydrogen here and 2 hydrogen in here. So that gives us total of 4 hydrogen. So we have to put a 2 here to match the hydrogens. So we get 2 times 2, 4 hydrogens. Okay, now to match the oxygen, you can see there are 2 oxygens in here, and if you notice carefully, there is 2 oxygen in here. Alright, the sulfate, the oxygen in the sulfate is already present in the sulfate, so we do not need to count it separately. Universal indicator turns purple in potassium hydroxide solution. What is the pH of the solution? So potassium hydroxide is alkaline, so the pH cannot be 1, 4 or 7. 7 is neutral, it will be 14. A student does a titration to find the volume of sulfuric acid that reacts with 25 cm³ of potassium hydroxide solution. Figure 7 shows the equipment used. We can see measuring cylinder, potassium hydroxide solution, conical flask indicator, and we have the sulfuric acid in the burette. The 25 cm³ potassium hydroxide solution is measured using measuring cylinder. Which piece of equipment could the student use to measure the 25 cm³ of potassium hydroxide solution more accurately? To measure more accurately, we can use a burette or a pipette. So in this case, we can use a pipette because it's a fixed volume. 25 cm³ can be measured using a pipette. Describe how the student would use the equipment in figure 7 to complete the titration. So guys, in this one, we'll have to write the entire process, alright, of how the student will do the titration. So, if we look into this particular diagram, alright, so what can we see? First of all, what do we have to do? We will have to add the potassium hydroxide solution to the conical flask. Once we add the potassium hydroxide solution to the conical flask, we're going to add the indicator to it, which will give us an indication that this is a alkaline solution. Then we're going to set the burette on top of this conical flask and add the sulfuric acid from the burette until the color of the indicator changes. We will first add a little bit faster, and then gradually, as we will see that the indicator is it's changing the color, but then it's coming back to its own color, original color of the potassium hydroxide slowly. Then we're gonna add drop by drop, and then finally until the indicator changes color, we're gonna keep adding, and then we're gonna read the volume from the burette. So this is how we should be writing the answer. This question is about metal carbonates. A student investigated the reaction of copper carbonate with an acid. Figure 8 shows the apparatus. So we can see the stopper, we can see gas syringe, 25 cm³ of the acid. This is the method used. Pour 25 cm³ of the acid into a conical flask. Point number 2, weigh 0.1 copper carbonate. Remove the stopper and add the copper carbonate to the flask. Quickly replace the stopper. Record the maximum volume of gas collected in the gas syringe. Repeat steps to 1 to 5 with different masses of copper carbonate. Figure 9 shows the gas syringe during the experiment. So we can see the gas syringe. We can take the reading from here. This is 45. So this will be 46, 47, 48. What is the reading on the gas syringe? So the reading is 48. The student plotted the results on the graph, shows the student's graph. Okay, we can see, all right, the student's graph. All right, mass of copper carbonate represented in here, volume of gas in cm cube collected. Okay. Determine the gradient of the line of best fit. Calculate the values of the change in y and change in x. Calculate the gradient of the line of best fit. So change in y. Okay. So in terms of change in y, we can see, let's do a little bit extra plotting. So this is 90. So 90 here, and this is 20. All right. So starting change in y is 90 minus 20, which is 70. Okay. Now for the change in x, we started at 0.1 and we finished at 0.5. So 0.5 minus 0.1, 0.4. Okay. Now we need to calculate the gradient. We know that gradient is equals to, all right, rise over run. So 70 divided by 0.4. cm cube divided by 0.4 gram. So we can conclude 175 cm cube of gas will be produced per gram. Copper chloride was produced in the reaction. Which acid reacts with copper carbonate to produce copper chloride? Okay, so if we want to make chloride salt, we have to use hydrochloric acid. The reaction between copper carbonate and the acid produced a gas. So since it is a carbonate, so definitely is going to produce a carbon dioxide gas. A different student produced a pure dry crystal of copper chloride using the same reaction. This is the method used. Add an excess copper to carbonate to the acid, filter the mixture, heat the solution gently until crystals start to form. Leave it for 24 hours, remove the crystals, rinse with water and dry the crystals. Why was the solution gently heated in step 3? So basically, we want to evaporate the water. We want to remove the water as much as possible before the crystallization process is triggered. So evaporate water. How should the solution be heated gently in step 3? All right. So to heat gently, we can use either an electric heater or we can use a boiling water bath. Electric heaters are gentle in terms that they can heat evenly, all right, and the change in temperature is gradual, whereas a Bunsen burner can have different temperature at different ends of the Bunsen burner, which can be a little bit troublesome because some salt, they're sensitive to temperature, and when they are exposed to high temperature, they can decompose. This question is about electrolysis. Some student investigated the electrolysis of silver nitrate solution. These electrolysis produce silver at the negative electrode. Figure 11 shows the apparatus. So we can see DC power supply, electrodes, silver nitrate solution, which is the electrolyte, and the beaker in which we are doing the experiment. This is the method used. Weigh the negative electrode, set up the apparatus shown in figure 11, switch on the power supply, switch off the power supply after 5 minutes. Rinse the negative electrode with water and allow it to dry. Reweigh the negative electrode. Repeat steps 1 to 6 for different amount of time. Some silver did not stick to the negative electrode but fell to the bottom of the beaker. The student needed to weigh this silver. How could the student separate the silver from the silver nitrate solution? Obviously, this silver that dropped at the bottom is a solid and it is insoluble, so we can just simply do filtration. Table 5 shows the student result. We can see the time and we can see the mass of silver collected. As you can see, when the time is increased, the mass of silver collected also increases. Draw a graph on figure 12. Use the suitable scale for the x-axis. Plot the data on table 5 and we will have to do a line of best fit. Okay. Determine the mass of silver that would be produced after 12 minutes. So to find out the mass of silver at 12 minutes, we'll have to extrapolate. We'll draw a line at 12 minutes. We're going to draw a line on the y-axis at 12 minutes. Okay, 0.11, 0.12, 0.13, 0.14. A student investigated the electrolysis of two aqueous salt solution. Hydrogen is produced at the negative electrode when the metal in the salt solution is more reactive than hydrogen. Complete table 6 to show the student what the student would observe at the negative electrode for each salt solution. Okay. So for copper sulfate, you see negative electrode is going to attract positive ion. In copper sulfate solution, the positive ions that are present, they are copper 2 plus, and because it's a solution, it also contains hydrogen ion. Because copper is less reactive, so we're gonna see copper being deposited. So since copper gets deposited, copper has a color which is like, pink, we can say orange, we can say red, brown solid, we can give it this kind of colors. So we will say pink brown solid deposited, pink brown solid, or we can say brown solid. For sodium chloride, the positive ions that are present, they are sodium and hydrogen ion. Unfortunately, sodium is very reactive, so hydrogen will be produced. So we will see hydrogen. Now hydrogen is a gas, so gas will be forming bubbles. So we can write bubbles, or a better word would be effervescence. A teacher demonstrates the electrolysis of molten lead bromide. The product at the electrodes are lead and bromine. Why should the teacher do the demonstration in a fume cupboard? Bromine is a halogen, and all halogens are toxic. Even lead vapor is poisonous. Two other molten compounds are electrolyzed. Complete table 7 show the molten compounds and their products. So if we have zinc chloride, we're gonna get, at negative electrode, we're gonna get the metal. So we're gonna get zinc. And at positive electrode, we're gonna get the non-metal, which is the chlorine. So for potassium and iodine as a product, we need potassium iodide as a reactant. Okay guys, that's all for today's video. That's the end of question number 7. Guys, videos like this will be uploaded every day. So if you subscribe to the channel, you will get this video notification. Alright, you can mute the notification since I'll be uploading so many videos every day. Alright, and guys, you can subscribe to the channel and you can get notified. That's one advantage. The other advantage is you can also let me know what kind of question paper that you want me to solve. Definitely I'll help you with that. My plan is to basically upload chemistry, biology, physics related question paper, all right, from all the exam boards basically. but I'm gonna do them in a serial, so that is to, it's a little bit easier for me. All right, and I hope you're gonna be, you guys are gonna be helping me throughout the process. You're gonna give your valuable comments. All right, you're gonna let me know how you're feeling about this particular videos. And I made the video short because most of the videos are getting about like 2 to 3 minutes watch time, which causes the YouTube to basically, to algorithm downgrades the video. So I made the video short, but however, I'll put them in a playlist and I'm gonna separate them out so that you can easily view the videos that you need to view. All right guys, thank you so much. Best of luck with your exam. See you in the next video. Bye bye.